Hello students, we'll be discussing relative basicities of amines today about aliphatic amines versus ammonia. Ammonia has lone pair of electron on it, due to which it is basic, as well as amines are having lone pair of electron on nitrogen. In aliphatic amines, R group is electron releasing, that is, it is having plus I effect due to inductive effect. Plus I effect of R increases electron density on nitrogen in comparison to ammonia, hence it is more available and makes aliphatic amines more basic in comparison to ammonia. When amines accept a proton and convert into ammonium ion, the positive charge on nitrogen also gets dispersed by plus I effect of R group. Then also it is increasing the stability of ammonium ion by plus I effect. Among primary, secondary and tertiary amine, due to inductive effect alone, we can say due to availability of 3 R groups in tertiary amines, 2 R groups in secondary amines and 1 in primary amines, tertiary amines should be most basic, then secondary, than primary, but it has been found that secondary amines are most basic. So, inductive effect alone cannot be the only criteria for deciding the basicities. We can see in case of methylamines, secondary methylamine, that is most basic, then primary methylamine, then tertiary, that is trimethylamine. But in case of R is C2H5, diethylamine is most basic, as well as here dimethylamine is most basic, but here tertiary amine was least basic, but here the tertiary amine triethylamine is having greater basicity in comparison to ethylamine, which is primary one. There is different order of basicity in the two. The reason for that, we can say that in case of ethyl amines, ethyl group has greater plus I effect because of 3 ethyl groups. Plus I effect dominates over another factor which we'll be discussing after that, the solvation effect, which also affects the basicity. Here plus I effect dominates the solvation effect and hence becomes the deciding factor. Hence diethylamine most basic, then triethylamine and least basicity is of ethylamine, that is of primary amine. Here tertiary amine, that is trimethylamine, was least basic because plus I effect of methyl group, which is smaller in size, is lesser in comparison to ethyl group. Hence the solvation effect also influences the basicity. Solvation effect is when these amines, primary, secondary or tertiary, are dissolved in water, they form ammonium ions. In case of primary amine, we can say this RNH3 positive ammonium ion is formed. Now in this ammonium ion, there are 3 hydrogens which can be solvated by 3 water molecules through hydrogen bonding. We can say 3 hydrogen bonds are there which are stabilizing the ammonium ion through solvation. In case of secondary amine, R2NH, R2NH2 positive ammonium ion is formed. Here 2 hydrogens are here and they can form hydrogen bonds with 2 water molecules. Here 3 water molecules for making hydrogen bonds. In this case secondary amine, there are 2 water molecules which can form hydrogen bonds. In case of tertiary amine, which form this ammonium ion R3NH positive, can be solvated by 1 water molecule only. So greater the solvation energy, greater is the stabilization of the ion and most easily it is formed. Hence we can say on this basis that primary amine should be most basic, then secondary, then tertiary, and by the combined effect of the 2 factors, that is inductive effect and solvation effect, it has been seen that secondary amines in all cases have the greatest basicity. Now, in case of methyl amines, that is trimethylamine, dimethylamine and methylamine, if are taken in gaseous phase, we can see here in gaseous phase solvation is not there, hence no question of solvation energy, only inductive effect is the deciding factor for comparison of basicity among these 3 types of amines and also comparison of these 3 amines with ammonia. 3 electron releasing group, most inductive effect in this case tertiary amine, then secondary, then primary, and in comparison to ammonia all these are more basic. So the order of basicity in gaseous phase is only on the basis of plus I effect. If the same solutions are taken in solution phase, then we'll see secondary amines most basic, then primary amine, then tertiary amine, because this is the effect which is the resultant of 2 factors, that is inductive effect as well as solvation effect. Now we can compare the basicity of aromatic amines. Aromatic amines, these are weaker bases than ammonia. The reason being, this aromatic amine, that is aniline, this is having 5 resonating structures. In these 5 resonating structures, we can see only 2 resonating structures are showing lone pair of electrons on nitrogen. In structure number 2nd, 3rd and 4th, there is positive charge on nitrogen, hence the electron pair on nitrogen is less available than ammonia, and so we can say that aromatic amines, these are weaker bases than ammonia. Now, if we take mixed aliphatic aromatic secondary and tertiary amines, this is secondary amine. Here one is aryl group and the other one is alkyl group. This is termed as mixed aliphatic aromatic secondary amine. Similar is the case of mixed aliphatic aromatic tertiary amine, where there will be we can say two aryl groups, two alkyl groups are there and one aryl group is here. In these cases, these are slightly stronger bases than purely aromatic amines because one factor, electron pair on nitrogen of mixed amines, this is more available because of the plus I effect of alkyl group or two alkyl groups in case of tertiary amine in comparison to purely aromatic amine. Secondly, the substituted ammonium ions obtained from mixed amines, these get stabilized due to dispersal of positive charge by plus I effect of R group. So because of these two factors, we can say mixed aliphatic aromatic. This is also an example of mixed aliphatic and aromatic. This was secondary amine, this is tertiary amine. These are more basic due to these two factors. One factor, this is electron releasing effect of alkyl group, that is plus I effect. Here two alkyl groups are releasing electron towards nitrogen, making the electron pair more available on nitrogen. And second factor, the ammonium ion formed in this due to plus I effect of R group, the plus charge that is more dispersed by alkyl group. Now we can discuss effect of substituents on basicity of aromatic amines. If some group is substituted in the ring, if the group G is electron releasing group, then on protonation of this amine, the ammonium ion which is formed, that gets stabilized because of the electron releasing effect of this group G. And when the G is electron withdrawing group, this ammonium ion formed that gets destabilized because of electron withdrawal by this G group. Intensification of positive charge will be there, and in this case, because of electron release, dispersal of positive charge will take place, hence stabilizing this ion. The electron releasing groups can be methyl, methoxy, amino, methyl or any alkyl group, alkoxy group, amino group, NHR group, NR2 group. All these release electron towards the ring, and electron withdrawing groups like nitro, cyano, halo. These withdraw electrons and decrease the electron density on nitrogen and destabilize the ion, thus decreasing the basicity. We must note that all groups, whether electron releasing or electron withdrawing, decrease the basic strength when present in ortho position. In aromatic amines, at ortho position, any group, any diene group, whether it is electron releasing or electron withdrawing, will decrease the basic strength, and this is known as ortho effect. The reason for ortho effect is not clear yet, but we can say in nutshell that any group when present in ortho position to amino group will decrease the basicity of the aromatic amine. For example, in para and metatoluedenes, these will be stronger bases than aniline, but orthotoluidine, that is weaker base than aniline. We can see some important observations also. One is electron releasing groups exert greater base strengthening effect when present in para position than when present in meta position. We can see para-toluidine, that is stronger base than metatoluidine, than aniline. We can compare the pKb's of these three. pKb of para-toluidine, that is 8.93, metatoluidine 9.31, and aniline 9.387. This shows that para-toluidine is most basic among the three. Second, electron withdrawing groups usually exert greater base weakening effect. We have seen that electron withdrawing groups, they weaken the base. This effect is greatest when these withdrawing groups are present in para position than when present in meta position. This is showing that aniline is most basic of all these three. When these withdrawing groups are present, these will withdraw electrons from the ring, hence will be weakening the basic strength. This effect is more pronounced when withdrawing group is present at para position in comparison to when present in meta position. pKb values of all these three we can compare. Aniline, we have seen it is 9.387. This is greatest of all. pKb of metanitro aniline is 11.5. Paranitro aniline is 13. This is aniline is most basic of all the three. Now, how to explain this effect? We know nitro group that has minus I effect as well as minus R effect. It withdraws electron from the ring through inductive effect as well as through resonance effect. When present in meta position, nitro group that does not come in conjugation, and here only minus I effect will be operating. Resonance effect is not shown by this metanitroaniline. So electron density will be withdrawn by minus I effect alone. But when present in para position, here electron density is withdrawn by two factors, inductive effect as well as resonance effect. So through these two factors, electron density will be withdrawn from this amino group, hence making it least basic. In case halogens are present, we can see that base weakening effect is greatest when halogens are present in meta position than when present in para position, because halogens have minus I effect and plus R effect. Through minus I effect, these will withdraw electrons, and through plus R effect, these will release electrons. But here minus I effect is greater in comparison to plus R effect, so domination of minus I effect is there. So in meta position only minus I effect is there, and in para position through minus I effect it is withdrawing the electrons, and through plus R effect it is releasing electrons towards ring. Hence in this case the greatest base weakening effect is at meta position, because here no compensation of electron withdrawal is being made through plus R effect. Here compensation is being made through plus R effect also, making aniline most basic in comparison to parachloroaniline, in comparison to metachloroaniline. In case of alkoxy and hydroxyl groups are there, these groups are having minus I effect, they withdraw electrons through minus I effect and release electron through plus R effect, but plus R effect is greater than minus I effect. Hence here when methoxy group is in para position, it is releasing electrons towards ring. At the same time, it is withdrawing electron through minus I effect, but electron release is greater in comparison to minus I effect. That is, overall effect is electron releasing, so making it more basic. In comparison, when the group is at meta position, at this meta position only minus I effect is there, that is, net effect is electron withdrawal, making this metamethoxyaniline weaker base in comparison to aniline. So the order of basicities is most basic is paramethoxyaniline, then aniline, and then metamethoxyaniline. We must note that a substituent which increases the basicity of an amine decreases the acidity of a carboxylic acid and vice versa. That's all.